So we're going to begin today with 7.6, which is your last and final section for chapter 7. And these are going to entail a lot more quadratic trig equations. Again, we're going to do some AC factoring. We're going to do quadratic formula. And I'm going to give you a couple more where you just plain factor and solve them. So again, these type of questions will lend themselves to situations with various number of solutions. You guys saw some 2s yesterday. You saw some questions with 4 solutions. You will see some instances with just 3 as well. And you'll see somewhere you have to reject something that doesn't work. So I want to start right at the top here. And I'm just going to start with number 1 again, but these are going to be very similar to the type of caliber that you solved yesterday. So I'm going to call these are mostly quadratic trig equations. I think at the end I did get away from that, but for the most part, quadratic trig equations. And your directions are going to say solve all of these in the interval from 0 to 360 again, because that is the most typical interval that we use. That is how your test is written and your review. So all of these questions are going to be find all angles that satisfy. So find all angles that satisfy. And again, any of your 4 quadrants. So 0 all the way up to 360, but not past that. And these first couple, we're going to go nearest 10th again, okay? So these are not going to be anything you know exact value for. Nearest 10th. All right, so number 1, we're going to go with a tangent function. So we're going to go 2 tan squared theta. And again, just make sure your squared goes on your trig function, but you guys done a good job with that so far. And then plus 3 tan theta. And then plus 4. And this is going to be equal to 3. Okay. So a couple things we need to train you to look for. First of all, is there only one trig function here? Yes, so that is good. Second thing you want to look at is this is a quadratic trig function because tan is squared. What have you been accustomed to getting quadratic equations equal to? 0. So you're going to do the same thing. You're going to go -3, -3, just like, again, you have always done in the past. So I'm going to go 2 tan squared theta plus 3 tan of theta and plus 1 equals 0. Okay. The fastest way to solve a trig equation with a quadratic is still going to be the factoring. Okay. So your factoring, does this have a GCF? It does not. Is it dots? It's not. Is it a trinomial? No. What you might want to do on the side, if it is helpful, is this. 2x squared plus 3x plus 1. Because then the method might jump out to you a little bit clearer. So what method is this? AC method. So again, just look at the trinomial instead. What numbers multiply to 2 and add to 3? 2 and, yeah. So 2 and 1. But instead of writing this as 2x and 1x, I instead include tangents. So I'm going to write this as 2 tan squared theta plus 2 tan theta plus 1 tan theta, or just tan theta, and plus 1 equals 0. If you can't make that jump, you are more than welcome to work with this trinomial, put the x's in, and then replace it with tangent. Again, until you get comfortable with those, whatever works. Now you're going to do your grouping. On the left-hand side, I can remove 2. Tan theta is my GCF, leaving me with tan theta plus 1. Other side, I can remove 1 only, and I'm left with tan theta plus 1. Okay, so yes, it still applies to trig functions. So what remains is 2 tan theta plus 1, as well as tan theta equal to, oh, sorry, plus 1. Jumping ahead of myself there. All right, and now we're going to t-chart these. So we have on the left 2 tan theta plus 1 equals 0, as well as tan theta plus 1 equals 0. And I'm going to continue. So I would have here the tan of theta is equal to negative 1/2, as well as the tan of theta is equal to negative 1. Okay, so on my other side here, I am looking for which quadrant is tangent negative. ASTC. Quadrant 2 is, yep, very good. Again, if this place right here, you have worked with the negative, so you may ignore it. In the calculator, you are going to type second tangent, which is inverse tan of 1/2. And this is going to give you your reference angle that you use to finish. Oh, I didn't write that one down. What is this reference angle? Tangent 26.6. Thank you. Appreciate that. And now you're just going to make sure that it falls into quadrants 2 and 4. So you're going to go 180 minus that value, 360 minus that value, and those answers should come back as 153.4. And quadrant 4 would be 333.4. Okay, so it's going to end the same way that you saw yesterday. Now I go over to my other side, and I want where tan is negative, which is located in those same quadrants. So again, using quadrants 2 and 4, negative is taken care of. This one, I hope you actually know. What angle produces a tangent of 1? 45. Good. Yep, so that one was exact value. Then I continue and I do 180 minus 45, which is 135, as well as 360 minus 45, which is 350. So there are your 4 answers from this. All right, how do we feel with the AC with that? Okay, I know, it does take a little bit of getting used to. All right, so over to another one here. I'm going to just flip this because these get kind of big. All right, so number 2, I would like to go negative 8 tan squared theta. Negative, oh, sorry, 8. I go tan squared theta and minus 4 tan theta. And let's go minus 11 equal to 6 tan theta minus 8. Okay, so again, I'm going to ask you, are we all in terms of tangent here? Yes, so that is good. This is another quadratic trig equation, meaning I need to get this equal to 0, and it is highly advisable that your squared term be positive. So I'm going to shift everything on the left-hand side actually over to the right. So I'm going to go positive 8 tan squared theta. Take your time with this. And then I'm going to go 6 plus 4, so I'm going to have plus 10 tan theta. And negative 8 plus 11 would give me 3. So I wanted to throw you another one of these because I know it keeps getting used to. Will this factor? Yes. This is nothing more than 8x squared plus 10x plus 3. Meaning we need to multiply to 24 and add to be 10. So what's going to work here? AC method, yep, using what numbers? 6 and perfect. Or would it help to flip those? Probably. Yeah, I'm going to flip those. That's all right. So we're going to go 8 tan squared theta. And I'm going to go plus 4 tan theta first. It doesn't matter, but that might make your GCF easier. Plus 6 tan theta plus 3 equals 0. All right, so you're going to group it right down the middle. So I'm going to take out a 4 tan theta, leaving me with 2 tan theta plus 1. Other side, I can take out a 3, leaving me with 2 tan theta plus 1 equals 0. And then you're going to set up your cases like you did yesterday. So I go 4 tan theta plus 3, and then 2 tan theta plus 1, and then take each case. So this would give me 4 tan theta equals -3. This would give me 2 tan theta equals -1. So I have the tangent of theta equals -3/4, as well as the tangent of theta equal to -1/2, which looks familiar. Didn't we just do that one? Yeah, we did. So those answers you can kind of just steal in a moment. All right, so continuing here, I have tan is negative once more in quadrants 2 and 4, and tan is negative in quadrants 2 and 4. Again, they don't have to always work like that. It's just the situation that you're given. So then in your calculator, once more, you're going to hit the second key, followed by the tangent of 3/4, which is not anything you would need to know. It's not exact value. And then second tan of 1/2. And then you're just going to appropriately place your answers in their respective spots. All right, so answers. Well, from this picture, we already had these from your other problem. This was 153.4 and 333.4. Again, you do sometimes get these to come up more than once. This guy would have been 143.1 and 323.1 as well. So another situation with those four possible answers. All right, how do we feel on that so far? Still okay with the AC? Okay. So number 3, I want you to tell me what's different. Have your formula sheet handy, please. We're going to make another heading. These are quadratic equations with identities if you want a title. Not that I want to give it away, but all right. We're going to go -2 cosine of 2 theta plus 12 is equal to 4 sine theta plus 9. What's different about that? There are 2 trig functions. Okay. Now, it's okay if you have 2 trig functions if you're able to separate them using a GCF. Is this going to be anything we can do a GCF for? No. So then what you need to turn to is your formula sheet. And you need to look at cos of 2 theta versus sine of theta and ask yourself, do you know something about it? Sine of theta, like we've said in the past, there's really nothing you can do with that. That has to stay. What about cos of 2 theta? Can that be rewritten using just sine? It can. It's on your formula sheet. Which identity was it? The third one down? No, the second one down. So you're going to replace that. So we're going to go 1 minus 2 sine squared theta. So you're going to replace that. And then you're going to be able to solve normally. but we changed it in terms of sign because that's what we were given on the right-hand side to work with. So now you're going to distribute. That's the hardest part. So I do -2 plus 4 multiplied by sine squared theta plus 12 equal to 4 sine theta plus 9. Is it still quadratic? It is, so it still needs to be equal to 0. So we're going to start shifting everything left. So we have a 4 sine squared theta in the front. -2 plus 12 is 10, minus 9 is 1. And minus 4 sine theta here. Okay. Will AC factoring work with this as well? It will. I'm going to do one more with AC, and then your next example, I am going to show you how you could use quadratic formula instead, because sometimes you do have to. But this is another nice example of AC. So I go multiplies to 4, adds to -4 would be -2 and -2. So -2 sine theta minus 2 sine theta plus 1 equals 0. GCF, a 2 sine theta, leaving me with 2 sine theta minus 1, and 2 sine theta minus 1. Remember, you gotta take something out, even if it's just that 1. Now I'm going to T-chart. I get 2 sine theta minus 1. Oh, and another identical copy of 2 sine theta minus 1. So do you have to do both of these? Clearly not. So clearly not. So this is not going to have as many solutions as those questions that preceded it. So I go 2 sine theta is equal to 1. So sine of theta is equal to 1/2, which is positive in quadrants 1 and who knows it? 30 degrees, very nice. This is exact value. So this is a 30-degree reference angle, meaning that my other answer is 150. All right, so 30 and 150, just 2 solutions for that type. All right, so number 4. I'm going to flip it just because I want you to get the space. I don't know definitively yet. So number 4, let's go. 7 cos squared theta plus 5 is equal to 2 sine theta plus 7. I want to point something out here too that gets easily confused. So does everyone see how there's 2 different trig functions? Okay. On the right-hand side where it says 2 sine theta, that does not mean sine 2 theta. You guys see the difference? This is not a double angle identity. Look very careful at your formula sheet. Your formula sheet has to say sine 2 theta. It does not. So this has to stay. There is nothing you could plug in for that. What about this one though? And it's been a while since you did this. Say it again. It's a Pythagorean identity. Very good. Yep. So you learned that sine squared theta plus cos squared theta equals 1. Therefore, cos squared theta is equal to 1 minus sine squared theta. You guys remember doing that? That's why those were important. So again, that is a Pythagorean identity. And now you're good to go. So I distribute, leaving me with 7 minus 7 sine squared theta plus 5 equal to 2 sine theta plus 7. And I'm going to get this equal to 0, but I need to unfortunately move over to the right-hand side. So move that over, I get 7 sine squared theta plus 2 sine theta. Excuse me. 7 and 5 is 12. 7 minus 12 is -5 equals 0. I am well aware that this would factor, but I want to show you how to do this with quadratic formula because you will encounter cases that don't always factor. So here's how you do quadratic formula. This is my A, this is my B, this is my C. For the time being, you may ignore the trig function and just do quadratic formula. So x is equal to -b plus and minus the square root of b squared minus 4 times a times c all over 2a 14. So x equals -2 plus and minus the square root of 144 over 14 is what you're going to get. And again, this only works out nicely just because it would have been factorable, but your procedure remains the same. So now I have x is equal to -2 plus and minus 12 over 14. And now you're going to put your sign back in. Okay? You're going to do your cases now. So I'm going to say sine theta is equal to 2 plus 12 over 14. So sine of theta is equal to 1, and we'll work with that in a moment. And then my other case would say sine theta is equal to 2 minus 12 over 14, which means sine of theta is -10 over 14. Excuse me. Okay, and now you just solve it normally. On the left-hand side, sine of theta equals 1. What do I have to draw? It's not a triangle. Unit circle. On the unit circle, sine corresponds to your y value. Where is my y value? 1. 90. Yep, right there. So my first answer is just 90. Now I go over to the other side, and this is going to be triangles. Sine is negative beneath the x-axis. And go ahead and do second sine of 10/14 or reduce it for that matter. And then there's those 2 answers. All right, so what do I have here? I am left with angles of, like, I don't know, what did we get? 45.6? So 45.6. So then you're going to just go 180 plus 360 minus. There, do you have those? No. Okay, so keep going. Oh no. Hold on. I see it. I'm sorry. You guys notice that? My mistake. I'm sorry. I dropped a negative. I apologize. Ugh, I apologize. These things happen, unfortunately. Okay, so let's change this up a little bit. So this is going to be -2 plus 12, so 10 over 14 on this side. Let me back this up. See what happens when you forget a teeny negative. Teeny negative. I don't know, you guys do the same thing too. Told you just started a little bit too long. Okay, so I have sine of theta equals 10 over 14. Okay, our reference angle should still be the same though. This is just going to bump me to quadrants 1 and 2. What was it, like 45 point something? 45.6. Thank you. Which means that our other answer is 180 minus 45.6, which was 134.4. Okay. Over to this side. Be careful here. -2 minus 12 over 14, which is equal to just -14 over 14, which is -1. Which is still unit circle, but where is it going to be instead? Where's our y value? -1. Yeah, 270. There we go. This is 270, which is your ordered pair 0, -1. Okay. This might be the first occurrence of just 3 answers. I can't remember if that came up yet or not, but that is a possibility. So 45.6. 134.4, and lastly 270. Okay, and we're going to stop there for today. How do you feel with the identities, quadratic formula, and the ease of factoring with those? Do you feel okay? Okay, so your homework, I only need you to complete 1 through 6 on that sheet. You don't have to go any further. You are technically able to, so if you want to and you're bored, you certainly could, but just 1 through 6 on that worksheet for tonight, please.